Miss Michelle, and today we're going to learn about the water flow process. And we're going to end with a really cool experiment with dirt. But first, let's look at these terms that are going to help us understand the process a little better. First, you have elevation. Elevation is the height above sea or ground level. In my picture, you can see this line here and this line here. This is your ground level line. This is your sea level line. They're at the same point in elevation. It's an imaginary line. We talk about elevation in terms of how high is the ground. So if you have a hill or a mountain, you're at a positive elevation. We talk about how deep is the ocean at this point, how deep is the lake. We talk about an elevation as in below sea level. Is a negative elevation. Next, we have groundwater. Groundwater is water that is held underground in soil through elevation. It makes its way into streams, lakes, rivers, little tributaries. Another little picture you can see here where we have our ground level, our sea level, precipitation going into the soil, and the soil making its way with the elevation into the lake or whatever water source is around. Next, we have aquifers. Aquifers are just underground layer of water. It's a body of water underground like a lake. So in Indiana and all over the country, we have massive underground lakes called aquifers. And here's the picture of our ground level, sea level. We have a lake, and that aquifer down here you see is even lower in elevation than what most lakes are. Next, we have a water spring. A water spring is a place where the water from an aquifer flows out of the ground naturally. So when that happens, you're seeing the ground elevation getting very close to the ground level / sea level. And then some aquifers are a little higher than others in elevation. So when that happens, a pressure can cause a spring, which is going to allow water to shoot up naturally out of the ground, feeding a lot of lakes, rivers, streams. A lot of our lakes are there just because there's a spring that's going, and that aquifer is just exploding up into our world. So here, really quick, is a diagram on the screen. It might help you understand the groundwater flow. You see it on a bigger picture. I know you're not going to see the words very well. I apologize. But up here, in the higher elevation, you have your mountain streams where you get a lot of the runoff. And then you have runoff into rivers that make their way down into our oceans, where also is met with the groundwater that flows through the soil to the ocean. Really quick, here's a little more realistic view of this water flow. And in terms of elevation, you can see here, this bigger chunk is a lot higher. If this is the ground level, there's a lot more soil where you're seeing all the mountain ranges. You get a lot more rapid rivers and vicious water flow through there, gushing down with pressure going all the way to our oceans. And this middle zone is where you're going to see a lot more lakes and tributaries formed, maybe a few springs in that area. Over here in our lowest elevation of land, making its way to sea level, You're gonna have a lot of marshy areas, which is just like wetlands, and that's called the floodplain zone because the land is at the same level of the water. That water is bound to overtake the land at some point and flood. And so in elevation, we see how this river makes its way down and flows into the water source or ocean. And that leads us to our experiment that we'll get to here in just a moment, and I'll meet you right over there.